These are the intro to acids and bases notes. This video is going to be broken up into 3 videos. We're going to start with properties and characteristics of acids and bases. The second video will cover conjugates, and then the third video will cover naming. So, fundamentals of acids and bases. You might be familiar with an acid and a base. Acids we can recognize because their formula starts with a H, so starting with a hydrogen ion. Acids have a pH of less than 7. We're going to talk more about what pH means later in the unit. And acids in a reaction are going to donate an H+ ion in a solution. And they will dissociate to form H+ ions. One thing that is kind of interesting about these is that they're only going to ever break off one H+ ion. This HCl only has 1 hydrogen and 1 chlorine. But all acids, even if we look at something like H2S, which is an acid because it starts with an H, that is going to dissociate by breaking off an H+ ion, and then that other H is going to be stuck with the S, giving that a negative. So it always donates 1 H+ in a solution. Bases, we can recognize that their formula ends with an OH, so ending with that hydroxide ion. Bases or alkyne solutions have pHs of greater than 7. And in a solution or in a reaction, they accept hydrogen ions with that. When a base dissociates, it does dissociate to form OH ions. Bases are a little different though. If we had something like calcium hydroxide, CaOH2, acids only dissociate 1, whereas bases actually do dissociate both of their OH ions when they are dissolved. And we're going to talk more about that later in the unit. So what are characteristics? You are probably familiar with some things that are acidic or basic. Acids are electrolytes, which are ionic compounds that dissolve into ions. And so we've talked a lot about dissolving and solubility this year. And so acids are those ionic compounds that dissolve into ions. They often have a sour taste, and they react with metals to form hydrogen gas. Some examples of acids are given below. Bases are also electrolytes, ionic compounds that dissolve into ions. We saw both of those up here. Bases have a bitter taste, a slippery feel. Some examples are provided here for us as well. So we have acids, we have bases, and then we also have chemicals that are considered pH neutral. There are 2 ways a chemical can be pH neutral. The first one is that it fits the category of being both an acid and a base, meaning it has both that H+ ion and that OH-1 ion. And we only have one example of it having H and OH, which is H2O, which would be HOH, because each of these have a +1 charge. So water has fits both criteria for both an acid and a base. And the other way that a chemical can be pH neutral is if it doesn't fit either of these criteria. So it has neither that H+ ion or that OH ion. So any example would be any ionic compound that aren't hydroxides, because that OH is there. And so we've got that anything like sodium chloride, copper chloride, potassium iodide, any of these things, because they don't have that H+ ion at the start or that OH hydroxide ion that they're ending on, they are pH neutral. And so in both of these cases, being pH neutral means that the chemical has a pH value of 7. So how can we identify acids and bases? If we think of these simple definitions of acids, if something is acidic, then it has that hydrogen ion at the start. If something is basic, it has that OH ion as its negative ion. If it's neutral, it either has both of those or neither. And so we can use those to determine what is acidic, basic, or neutral. So looking at acidic, basic, neutral, well, HCl, that has that hydrogen, and so that is an acid. NaOH has that OH, and so that is a base or it is basic. HOH, well, it has both that hydrogen and that hydroxide, and so that would be considered a neutral substance because it has both of those characteristics. Feel free to pause this, try the rest on your own as you want, or follow along. H3PO4 has that H3, and so that is an acid. BaOH2, we see that OH ion, and so that is a base or basic. HBr, we see that H, so that is acidic. NaCl, I don't have an H or an OH, so that fits into the neither category, and so this would be neutral. And then H2O, well, another way to write that H2O is HOH, so it has both of those criteria, so this would be neutral as well because it has the hydrogen and the hydroxide. And so it fits into both of those categories with the hydrogen and the hydroxide. All right, so acid-base reactions. Generally, when we have an acid-base reaction or a neutralization reaction, we have an acid and then a base, and it can produce water, which is neutral because it has both the H and the OH, and a salt, which is just an ionic compound. So circle the acids in red, circle the bases in blue. These are some examples, and acid-base reactions are double displacement reactions. And so we're just switching their partners to form water and a salt. So all neutral products with that. So acids in red, well, acid HCl has the hydrogen. Bases in blue, that NaOH has the OH, so that is the base. HC2, H3O2, this one gets a little trickier, so let's look at the KOH. I see that OH, so this is my base, meaning this is my acid. It did start with that H, and so that is that indicator of being an acid. The last one, KOH, well, KOH, that's a base, and that HBr is an acid. So while in acid-base reactions, we often have an acid plus a base giving us water and salt, that's not always the case. If we go back and look at our definitions of acids and bases, we have cases where an acid starts with a hydrogen, but it also is a chemical that donates a hydrogen in a solution or in a reaction. And a base often ends with a hydroxide, but sometimes bases are accepting hydrogens in a solution. And so with this is the definition of Bronsted-Lowry acids and bases, because sometimes we will have both of our reactants maybe starting with an H, where they could donate an H, but we need to look at what reactant is actually donating a hydrogen and what reactant is actually accepting a hydrogen through that reaction. And that definition is what we use for Bronsted-Lowry acids and bases. And so as we look at these Bronsted-Lowry acids and bases, in acid-base reactions, one substance is passing a proton, that H plus ion, to another. And so the acid is the chemical that loses the proton, the H plus, and the base is the chemical that gains it through that reaction. And so if we look at this H2O plus H2SO4 producing HSO4 and H3O plus, both of these have hydrogen, so both of them could donate a hydrogen. What we need to look at though is that we have H2O. Well, how does that change? That becomes an H3O. So that H2O is gaining a proton. So by gaining a proton, that H2O is a Bronsted-Lowry base. And even though it could have lost a hydrogen, it gained that proton or that hydrogen through the reaction. And looking at that SO4 term, this went from being a H2SO4 to H1. So by losing that proton, our H2SO4 is classified as a Bronsted-Lowry acid. So if these don't fit in kind of that simple definition of having an H or an OH, notice both of these have an H. We do have that H2O with an OH, and in this case it's a base, but water can be an acid because it can be classified as both. So we need to consider who's gaining and who's losing through the reaction. All right, so identifying what compound is the acid and what is the base using that Bronsted-Lowry definition. So looking at this NaOH and that HBr, you might be able to identify what's your acid and what's your base. But if we consider this Bronsted-Lowry, we have an OH. This H2O would be HOH. And so what's happening to that OH? Well, that OH is gaining a hydrogen. And so by the Bronsted-Lowry definition, this is our base. Looking at my Br, well, what is changing with that Br? It goes from HBr to NaBr. So by losing or donating that hydrogen, HBr is an acid. Looking at our next one, HNO3 plus H2SO4. And with these, we only have one with a hydrogen, but let's make sure we understand those definitions. By looking at this H2SO4, I can anticipate that this is going to be my acid because it's the only chemical reactant that has H's to donate. I go from H2SO4 to H1SO4, and so that does donate an H plus through the reaction. So let's make sure then that our NO3 is gaining a hydrogen, and that NO3 we end with HNO3. So by gaining a hydrogen, that makes that NO3 minus a base by that Bronsted-Lowry definition. Feel free to pause the video and try the next one on your own. Looking at this one, both have hydrogens, so both could donate a hydrogen and both could gain a hydrogen. And so as I look at this, I'm going to just pick my fluorine to look at first. And over here is my fluorine. So what happened with that fluorine? Well, this lost or donated a hydrogen, which makes that HFR acid. And we should then see that my HCO3 minus, that CO3, we should see a gain or an accepting of a hydrogen, meaning that that is our base. Right, that is the end of this video. The next video will cover acid-base conjugates. Reach out to your teacher with any questions.